2 steps. Yeah.
Did you ever ask
Eventually.
empirical formula questions like 68 because 68% they're saying like 1, or I don't know if it's correct. But
No, we really didn't spend much time with those 68, 95. It only came up, and then we got right into the chart. So I'm not going to ask you a question with that. We didn't really spend a lot of time with that. Okay, now, so uniform.
Yeah, uniform probability.
Okay. 2 data sets.
I mean,
2 numbers.
Yeah.
So let's say I had a uniform distribution from 0.7 to 1.6. I would like it. Sounds like something I would do. Oh, this is going to be really yummy. Let me see what you guys think. That's creepy, I don't care. So can you draw that for me real quick? Draw it. What shape will it be? What does that mean? What did she say? Uniform. What shape is that? Big old rectangle, right? That's all. Big old rectangle. If I say uniform, you go, it's a rectangle. Sweet, thank God. As you should be your reaction. So I get way too many people that do this. They put 0.7, they put 1.6, and they maybe even put a height, but they still didn't draw the distribution anywhere. So like you said, it's got to be just this big ass rectangle. Hello.
Hello, rectangle.
Now can you take a minute or a second or somewhere in between there and figure out what the height's got to be? Yeah, 1.111, right? Yeah. So 1.111, you need to do 7 feet.
How do you find that?
Oh, okay. How do you always find that? So what's the width? 0.9. So the height's got to be the reciprocal. Now watch. If you want to be nicer to yourself, see you guys are cool with this. 1 over 0.9 is the same thing as chunk 10 over 9. Probably not going to give you one quite this ugly, but still, we should know how to do that. So you don't have to have this rounded decimal sitting there. Okay. Man. Getting like nothing for it. All right. So then if I ask you a question like, what's the probability that, what you got, x is greater than 1? Where's 1? Yeah, somewhere in here. And where's greater than 1 in my distribution? Is there anything past 1.6? No, so this is the only part I got to worry about. So how do I get the answer to that probability question? Get the area, like always. So how do I get that area? It's going to be neat color. 0.6 times 10 ninths.
Would it be incorrect if you did 0.6 times 1 over 0.9?
Do it again.
If you just didn't make your fraction 10 over 9, you left it as 1 over 9.
Oh, it would be fine. You just have to round if you do the 0.111, the 1.1111.
Yeah.
You got to stop somewhere, whereas 10 ninth has all of them in it.
Okay.
So then there's no rounding, but it wouldn't really affect it that much. 200 over 3. 200 over 3. Sorry?
These are still probabilities. So like for like the rounding.
Yeah, these are probabilities, right? This is a probability question. So yeah, you round it to 4 places. Right. Trying to see what I can get here. 0.6. Oh, is it 6? Okay. So you make this 0.666. Round it to 3. Oh, you're the one that's all smushed. I'm sorry, little buddy. graveyard. Is that okay?
Yeah.
All right. I'm not gonna ask you what the mean is, and I'm not gonna ask you what the standard deviation is. Did you have to do that in the homework? Yeah. Did you have to do it on the practice test? And sure, yeah, you sure did. All right. So let's talk about that, since the last two problems deal with number 6. Extra credit, what do you mean?
On the test, we have
Bonus questions, always. Yes.
so, I mean, which part is that? Which part how we have to work?
Do it again.
I mean, which part how we have to work? How we have extra? I mean, you know what?
No.
What-
So there will be extra credit questions.
I
Yes.
think he's asking what
What
part
part
of the
would-
chapter is it,
yeah.
but it's, you never tell us. It's
Oh,
always
hell no.
surprise.
How,
Yeah, bonus. I can make it whatever shit I want to. In my algebra class, I made one bonus question. Just tell me what your favorite Beatles song is. Because some Beatles came up in the class. Yeah, if any of you guys are watching. This one guy was like, "The Beatles suck," and oh my god, the next 5 minutes I couldn't control. You know, it's like everybody just needs to calm down. So just to kind of play with him a little bit, I put that question in there, and I made a word problem involving the Beatles. So just because. All right. But yeah, I can make, hopefully most of the time they will deal with the subject we're dealing with, but sometimes I make it something else just because I want to, and it's bonus. So look at number 6. Number 6 is the uniform distribution problem on the practice test. When we did this, where'd it go? When we did this, why did we do it?
Because the sample changed.
I took a sample, and I asked about the sample mean, right? Do you guys know how they figured out this number, 14.9 years? No, the answer is no. I just put the number down there. Do you know how they did it? No, who knows? They could have done it anyway. No matter where the shit that standard deviation came from, if I take a sample and ask about the sample mean, I have to do that. I have to change it. So look at number 6. This is why I love number 6, and I just so would. The first couple questions on 6 are normal, and let me pick a better word, are traditional uniform probability questions, right? Draw the picture, find the probabilities. The probability x equals 5 should be quick now. And then you get part D. Part D says, find the mean and standard deviation. So the mean, you look that up in the book, and it's a plus b over 2. And the standard deviation, of course, this is obvious. No, it isn't, kids. It is not obvious. But that's just what it is. Yes.
No.
These are the two formulas I said will not be on the test. Does that mean they are so not important anywhere? No, that's not what that means. It just means the test can only be so long. What do you want? So this is just plug and shove. Just plug and shove. So for number 6, what's the? It's from 2 to 8. So what's A and B? Yeah, A is 2, B is 8. Yeah, whatever. Emoji. So now I can just plug and shove. Right? 2 plus 8 divided by 2 is 5. Right? 5 is right in between 2 and 8. It's 3 away. Okay. Standard deviation, plug and shove. Square root of 8 minus 2 is 6 squared is 36 divided by 12 is 3. And then that's like 1.7, maybe? I always forget what square root of 3 is. Is it 1.7? 1.732. Okay. Don't you hate that? You forget what the square root of 3 is? All right. That's part D on number 6 on the practice test. Everybody with me? And again, it's not going to be in the real test, but it's just a couple of formulas to plug shit into. If anybody is curious why there's a 12 there, I can give you a printout of the derivation of this formula. Warning, it uses calculus. So. Alright. Okay. Part F is the really interesting question here. F says if we take a sample. Huh? What's up? Oh, I'm sorry. I went through E. That was D, yeah. I don't know, man. It says if we take a sample of size 43, can you tell me a couple things that happens once we do that? And I ask you a question about the question is all about the what the sample means. So what's got to change? Yeah, it doesn't matter. It does not matter that this is a uniform. I keep pointing up there. That's old shit. This is a uniform distribution. It doesn't matter. It has a mean. It has a standard deviation. If I take a sample from it and ask about what the sample mean would be, I've got to change the standard deviation. What's one other thing somebody can tell me? What's special about 43, the size of it? So I have a normal curve now. I want you to realize that's exactly like that colorful sheet. Remember I had it started off as a uniform curve, the numbers out of a hat, and then once I took just sample of 2, it was already looking really normal. So if I take 43, it's really going to look normal. Hello. So in 6, it's all about a uniform distribution, but 6E, I am going to use the z-score chart because it becomes freaking normal because the sample size is more than 30. So this whole thing we did in chapter 7, the whole thing about the central limit theorem, it does not give the first shit what the distribution originally looks like. The minute I take more than 30 sample size, you're working with a normal curve for your means. That's why I love number 6. Uniform, then I make it become normal. Right? So, I can draw the picture, sure, what's in the middle. 5. I want this area here, so you can see what kind of z-score problem this is. I need to make, and so before I make z-scores though, what do I need to do? Change standard deviation. So whatever the hell that is. So let me do this. Let me give you guys the answer key. Thankfully, I caught a few mistakes. I'm averaging about a 97 on my answer keys. It's not bad. So I didn't go through on each paper. I just copied it in color, so it's a green correction. Yes. I said you guys could do the other problems, and you could ask me, and we could do them. I just wanted to open it up in case people had questions besides that. Yeah. But yeah, you can ask me about the other problems. Oh shit! I think I'm getting some points. No, good. All right. Yay! What's up? You gotta be more specific. That was an approximation from the script. How we know. So I totally will ask this kind of question on the test. Find the z-scores bounding the middle 95%. of a normal curve. So you got a normal curve. So can you, like, what do you think of bounding the middle 95%? So where is that 95%? So there we go. There, right? Middle 95%. Cha-cha. Man, that was a really aggressive dance move. Cha-cha. 95%. Will the chart have a freaking clue about that area? What's the only area the chart understands? Areas that are below z-score. Can you tell me real quick, if this one was -2, this one has to be +2. Symmetry, right? So if I focus all my attention on finding this guy, I basically have that guy too. So how do I find this z-score using the chart? Well, I've got to know this area. So I'm not changing the question, I'm just using the right thing to find the answer to the question. So this 95 doesn't do shit for me. How much is outside? 95% inside? 5% outside? 2.5% on that side. Yes, sir.
Is that the same thing as asking for the mean? Because I thought the mean would be like X values, not Z-scores.
Oh, I'm working my way up there.
Oh.
I'm kind of taking that problem and cutting it into 2 steps.
Okay.
Because the problem we're looking at is actually this one. Find the sample mean ages bounding the middle 95%.
So you couldn't use like the empirical rule to do like 2 standard deviations?
Empirical rule was a quick estimation. So 95% is roughly bounded between 2 steps, 2 standard deviations. But we can be more precise now. Unfortunately or fortunately, right? So it ain't 2, it's something close to 2. Has anyone found the 0.025 yet on the z-score chart? And of course it's going to be a negative z-score because it's back here. And you guys get the idea? I'm always curious. I think I've said something like this before, but do you guys get this idea that, holy shit, it wasn't that bad, Jeff. All right. Wow. Okay. What's below here? 50%. So if I go like a step down, there's going to be less below there, right? So really, a way to look at this question is, how many steps do I go so there's only that much left below? And that's what the z-score chart tells me, is how many steps I have to take below. So, you finding it? 0.025?
Yeah.
What do you get?
-1.
You get exactly 0.25, right? That's different. Yeah, negative 1 point, which if you rounded it would be 2. But 2 ain't good enough because we're a little more sophisticated now. So what's this one? 1.96. All right. Sample mean ages bounding the middle 95%. So the sample mean age was 80.2. The standard deviation of the sample mean ages was 2.450. You see that? So I'm still going to use this formula. This formula here. Cool. But I'm going to put this here. And this there. And of course what goes here, we just figured out, negative 1.96 and then positive 1 point. I got to change each of them into an age. So then I can say 95% of babies born in 2004 in California are going to die before these ages. Right? What a wonderfully upbeat problem. So if the question is asking about the sample means, can I use 14.9 for my standard deviation? No, because that's for individuals. I have to use the 2.450 that we calculated. Yes?
So would you calculate it for, you calculate it with both z-scores?
Yes, I got to convert each z-score into an age. This age is going to be below 80.2 and this age is going to be above 80.2. That problem, to be really honest, that problem is something we can totally do right now, but it's actually sort of leading into chapter 8 eventually. So I'm going to come back to that problem when we get into chapter 8 and say, look, we did it already. Ah, it's amazing. How you guys doing? You all right? I'm worried about you. You know, right now is the time.
Same problem on the test with z-scores bounding within 90.
Sure.
And
I
that
love
doesn't
it.
make any sense.
Why not?
I don't even know where you came up with
Look, look, look.
numbers.
If I would have said z-scores bounding the middle 95, I would have stopped right there. Those are the z-scores bounding the middle 95. So how do you do the z-scores bounding the middle 91? The exact same way we did this. If it's the middle 91%, what percentage is on the outside?
9%.
Middle 91%. There's 9% outside. What percent is on that side? 4.5%. Stop for a second. Is everybody with me on that? If 91% of the people are in the house, 9% of the people are outside the house. And if they are symmetric to the house, 4.5% are on that side. Right? So 4.5% is right there. So instead of looking up 0.025 and getting this, I'm going to look up 0.045 and get the answer for that. Again, the normal curve is symmetric. So when I draw something that represents the middle whatever, these two are going to be the same number, different signs, because it's symmetric. No, don't just say okay. So if this is 0, and I've got to go down 1.7 steps to have this area left outside, that's what that means. So if you look up 0.045, I think it's this, you guys. Come on, stay with me. So how far up do I have to go? So I have 0.045 left there. Well, it's symmetric, so I have to go the same number of steps, 1.7. It's just up, so it's positive. Same thing we did here. This is symmetry. Now, if you don't quite trust me, watch this. What area is below this? 0.91, 0.045, so 0.955. You guys see that? You know, like, I see a bunch of ink on a whiteboard. That's about it, honey. Shit. Well, that's 91%, and that's 4.5%. That's freaking 95.5%, right? So if you look up 0.955, just try it. Look up 0.955. The closest I can get is 0.9554. And what's z-score say? 1.7. So if you want to do it the long way, you can do it that way, or you can just realize that whatever this is, that has to be the same number opposite sign because of symmetry. If this tail has 4.5% and this tail has 4.5%, these are the same distance away from 0 both ways. Has to be because of symmetry. You guys are loving this shit. So normally a little more talkative. You guys, trust me, if there's something you don't understand, look around. There are a few other people that don't understand the same thing, so feel free asking. Yes?
On your answer key, I noticed
See where am I at? See where?
1C.
Oh, greater than 2. So you could just add up the probabilities for 3, 6, 11, 12. I chose to do 1 minus the only one left out because they all have to be 1 anyway. It's that general idea of the probability something is 1 minus whatever it leaves out, because that's the opposite.
Oh, okay.
Yeah. So you got a couple different ways you can do that. Yeah.
Can you just go over one, like 2 examples? All of it.
1.
Yeah.
So this is where I'm going to give you this. Right. Line will probably be a little bit longer, but it's going to look like this. And then we ask you, is this a valid probability distribution? Anybody remember at all? Let me restate this. I told you this a while back. On the test, will the probabilities add up to be 1? Anybody remember? I already told you. They won't. Of course they won't. Because, well, I'm just going to get people that just memorize, I just write this shit down, make them happy. What you're supposed to do is check that. Check it. So I'm going to make it so that these, on the test, these will not add up to be 1. They will add up to be 0.9999 maybe, or 1.0001. Does that mean it's not valid? Of course it's valid. So if you get this, don't just say this, because then I'm like, is it supposed to be that? That's what it looks like. If you say this, oh, it's supposed to be 1.0001. Is that what you're saying? No. What's it supposed to be? It's supposed to, of course, be 1. So you say, I got this, showing Jeff that, yeah, I checked it, Jeff. Get off my back. And then you say it's approximately what it's supposed to be. So I see you know what it's supposed to be, and I see that you actually checked it. Maybe? Maybe. So there's a second thing I'm telling you will be on that test. Yeah. Maybe. When we did relative frequency histograms, did they always add up to 100% at the end? No. Why didn't that freak us out? Because what did we do to make them not add to 100? Sometimes we had to round. So just because they weren't exactly 100%, what did I say? They had to be close. So if you got 95%, no way. You didn't count somebody, right? So would you say that 1.0001 is close to 1? If not, I kind of like you in a way. Like, that's light years away, Joe. No, that's freaking close to 1. That is because of rounding. Okay, maybe. Okay. You guys understand that if you round stuff, you could randomly round up a little bit more than you round down, and that's why the answer comes out a little more than it's supposed to. Doesn't mean any math is wrong. It doesn't mean any of that. It's just because humans like rounded numbers. I don't want to see infinite decimals. Please do not. All right. And what else do you have to tell me?
That each probability is less than,
No.
or is
Between 0 and 1. That's good. Or you can just say this. All right. That one, I'm not going to make any of these negative or something freaky, so you just write that shit down. Just don't forget one of those two things, because then you lose these crazy points. You get angry at me, I'm like, write it down. All right. Now, that'll be like part A. Is this a valid probability? Part B is going to be find the mean, or part B would really be something like probability of 5. What's the probability of 5? Really just making sure you can read this shit. So what's the probability of 5? I have a special place in my heart for the people that say 1/3. No. What does this column tell you? Probabilities. So probably 5 is 0.3 or 30%. I like it. So that should be an easy question. I just got to make sure you can read this thing. And then I'm going to ask you, dollars. I'm going to ask you what's the mean and the standard deviation. And that, of course, is where you make this and you make this. So that you can plug those in. The nice thing about this column is when you add it, you're done. Because the mean is the sum of the xp of x's. This column is just a part of what the standard deviation formula needs. So you got to plug that number in the right place. So, you know, you could do this in your list 1, list 2, list 1 times list 2, list 1 times list 3. Or this is just a small, who gives a shit, 0.2, 1, 1.5. So when I add those, I get 2.7. That's the average. The average is 2.7. And then here, 1 squared times 0.2. I'm starting with the square. 1 times 0.2 is 0.2. 2 times 1 is 2. 5 times 1.5, I don't know, is it 7.5? I think so. Are you guys with me on this? This is, yeah. You got that handout I gave out, the workout problem? Yes.
Didn't you have to square before you multiply
I could either do this times this, which is x squared, or I could do this squared times this,
Okay.
which is x squared. And then if you add these together, you get 9.7. So that's the mean, and this, so the mean is the sum of xp of x, which came out to be 2.7. The standard deviation is the square root of this minus the mean squared. And then, you know, whatever that is. Yeah, it's on your formula sheet, hopefully. You're being kind to yourself. That is one of the ones we put up on there, yeah. So that was so I needed to make those so I could add them up so I could throw that number in.